All right, thank you so much for joining us today. And in this video, I'm going to show you how to answer exam questions and also how to solve them too as well. Don't forget, this is UIC exam 3, which covers all the topics that you need to know to prepare yourself for the exam. All right, so let's start. We are given a function f of x which is equal to x to the power 3 plus x, and then the most important thing here is the domain here. We want to find the absolute maximum and absolute minimum. So what's the first thing that we need to do, right? So you are taking an exam, you want to find absolute maximum and minimum. The first thing that we need here is we need the critical values. For us to get the critical values, we need f prime of what? X. So let's find for f prime of x. So we know that f of x is giving us x to the power 3 plus x. It means that f prime of x will be equal to 3x squared plus 1. So this is the first thing that we need, right? We need the f prime. Now we know that for critical values, our f prime should be equal to 0. So it means that for critical values, f prime of x should be equal to 0. So it implies that 3x squared plus 1 should be equal to 0. Now here we see that 3x squared is equal to negative 1 and x squared is equal to negative 1 over 3. Now remember, since this one is x squared, there is no way you are going to get a negative value unless x is a complex. So here it means that we are not going to have a critical value. So conclusion that we can make here is there is no critical value. There is no critical value. So if there is no critical value, then the question is how do we solve for maximum and minimum? We just need to use the domain, that is the endpoint. So now let's construct our table, which is we have our x and we have our f of x. So we have the domain, which is 2 and 10. So I have 2 here, I have 10 here. So let's find for f of 2 and then f of 10. Now don't forget our function is x to the power 3 plus x, right? So now let's plug in 2. What do we get? So f of 2 will be equal to 2 to the power 3 plus 2. This is 8 plus 2, and this is going to give us 10. So this is 10. Then let's plug in 10. This is going to be 10 to the power 3 plus 10. 10 to the power 3 is 1000 plus 10, and this is going to give us 10, 10. So this is equal to 10, 10. So this is going to give us the minimum, and this is going to give us the max. Good. So what the question says? Question says that we should state the absolute maximum in the point form. So in the point form means that we need to have x and we need to have the y. X and y. So what is the maximum? The maximum we had 10 and 10, 10. And then the minimum is 2 and 10. So this is what we need to do. So the key here is that it's not always the case that you need to find a critical value. And we learned that even when you get a critical value, you need to check if it is in the what? In the domain. So this is one version. Let's go through another question which goes through the same thing but another version, right? So let's talk about the other version. So other version, now we have this function. Still, we want to state the absolute maximum and minimum, but let's look at how we can go with this one too as well. So still we have our f of x. So we need to find the critical value. So x squared minus 3x plus 5. Then f prime of x is going to be 2x minus 6. So as you know, now we are finding critical values and we are saying that for critical values, f prime should be equal to 0. So for critical value, for critical values or value, f prime of x should be equal to 0. So it means that 2x minus 6 should be equal to 0. 2x is equal to 6 and 2 is equal to 3. So I divide through by 2 and I'm getting it to be 3. So you see that now here we have a critical value. But what is the important thing here? We need to check if this critical value is in the domain. Very important. Check if the critical value is in the domain. So now when you look at the domain, we can see that, okay, 3 is in the domain because between 0 and 5, there is 3 there. So it means that now our table is going to have 3 values, the endpoint, which is 0 and 5, and then critical value, which is in between 0 and 3, 0 and 5. So now let's look for f of 0, f of 3, and then f of 5. Another thing that you need to know here is anytime we are talking about absolute maximum and minimum, we are using the original function, not the derivative function. That's one thing that also you need to remember from here. So what is f of x? We had f of x to be x squared minus 6x plus 5. So let's just plug in 0. I love when you plug in 0 into a polynomial function, all the terms with the x goes away, and then it will be left with just the constant here. So we are going to have this one to be 5, right? 5. Let's look for f of 3. 3 squared minus 6 times 3 plus 5. 3 squared is 9. This is going to give us 18 plus 5. And 5 plus 9 is 14 minus 18. And this should give us minus 4. So this is going to give us minus 4. Let's look for f of 5. 5 squared minus 6 times 5 plus 5. 25 minus 30 plus 5, and this is going to give us 0. So this is also going to give us 0. So which one is the minimum? This is the minimum. And which one is the maximum? This will be the maximum. So let's go and write it in the point form. We are going to have the maximum to be 0 and 5. So maximum is 0 and 5. And then the minimum is 3 and negative 4. So minimum is 3 and negative 4. So this is how you go through whenever the question is asking you for absolute maximum or minimum. Pay attention to anytime you are doing this evaluation here, because when you get it wrong, it means that you are going to get this one wrong. For example, if I didn't simplify this one well, and then let's assume that I had 10, then it means that this one is going to be 10, and this is going to be the maximum instead of being this. So you need to also pay attention here. All right, so we have 10 questions. Stay here. Let's go through together. Let's look at this question 2 here. So here we want to use the evaluate the integral, definite integral using the fundamental theorem of calculus. So here we are restricted to use the fundamental theorem of calculus. You cannot use the area, right? So we just need to do that. So let's go through and see. So the fundamental theorem of calculus is actually the normal integration that we need to do. So let's just integrate this. What are we going to get? X to the power 3 plus 1 divided by 3 plus 1 plus 3x1 plus 1 divided by 1 plus 1. Because this is to the power 1. We are going to have negative 1 to 1, and this is going to give us x to the power 4 divided by 4 plus 3x squared divided by 2. From negative 1 to 1. So what are we going to get? Plug in 1 inside the whole function minus, then you plug in minus 1. So this is going to give us 1 to the power 4 plus 3 times 1 squared divided by 2 minus, I open the parentheses, I put negative 1 inside to the power 4 divided by 4 plus 3 minus 1 to the power 2 divided by 4. Now I know that this is, I'm going to get 0 because look at this. This is minus and this is 1, right? And since this is an odd function, when I integrate, I'm going to get it to be even function and it's going to send it to 0. So that's one thing that you need to know about integration. So this is going to give us 1 over 4 plus 3 over 2 minus, this is also going to give us 1 over 4 plus 3 over 2 because this is an even and making it positive, making this one too positive. So you see that everything here is the same thing here. So this minus this, so let me put this one in parentheses. So this minus this will be 0. Or if you want to simplify, this is going to give us, so if this one is 6, 4, I'm going to have 7 over 4 minus 7 over 4, and this is going to give us a big 0. So this is just the fundamental theorem of calculus. Let's look at the other version. The same question, but different version. Let's see what we are going to get here. So is this going to be 0? No, because this is an even function, this is an odd function, so they cannot cancel out. So let's do the integration. 6x squared plus 1 divided by 2 plus 1 minus, when I integrate a constant, I just multiply by the x, minus 1 to 1. Plug in 1, or let's simplify, 6x to the power 3 divided by 3 minus 4x from minus 1 to 1. Simplification again, this is going to give us 2x to the power 3 minus 4x minus 1 to 1. Good. So now let's plug this inside the whole of this. So we are going to have 2, 1, 3 minus 4, 1 minus, then I open a parenthesis because two function, 2 minus 1 to the power 3 minus 4 to the power minus 1. Okay, so this is going to give us 2 minus 4 minus, this is going to give us minus 2, and this is going to give us plus 4. So this is going to give us minus 2 here, and this is also going to give us 2 here. So this is minus 2 minus 2, and this is going to give us a big 4 from here. So that is the fundamental theorem of calculus. Let's look at question 3. I hope you are here with me. So question 3, you are a manager. So anytime I'm solving a question and the question is referring to me, I'm so happy. You are a manager, so it means that I'm the manager, right? Good. And then we are renting a hotel, and then the price for night is $60, and we're able to rent out 100 rooms. So anytime we increase the price above $1 above the $60, it means that one room, the rent one less room. So it means that we are going to rent less of the room. So let me put something here like current. So current means that the price that we are giving in the night was per night is $60, and the quantity, the number of room that we are going to rent out is 100. Let's talk about the new information when we increase price. So when we increase price by $1, what happens? We are going to rent one less of the room, but we are saying that one increase in price, let's denote it as X. So it means that the new price is going to be 60 plus X. So that if we just increase it by $1, we have $61. If we increase by $2, we have $62. Now, what will be the quantity? What will be the new quantity? The new quantity is going to be 100 minus X, because now when we increase it, we go less by 1. So 1 times X, and we are having the X. So what is the revenue function? What are we going to get for the revenue function? So revenue is price times quantity, and price is 60 plus X, and quantity is 100 minus X. Good. always check what is inside the parentheses here. So this is x, so this one should be in terms of x. Let's try and simplify this. 60 times 100 is 6000 plus 60x minus 100x minus x squared. Here, when you are doing your simplification, you need to pay attention to that. So this is going to give us 6000 plus minus 40x minus x squared. So this is the revenue that we are going to get per night. Right. Now the question is, find the price which maximize revenue. So we want to find price that maximize revenue. We know price. Price is already here, but we don't know x. So that is the only thing that we need to look for. So for us to maximize, it means that we need to find the derivative. So we need to pick the revenue because we want to maximize revenue. So we need to pick the revenue and then find derivative and then look for x. So what is r prime of x? We know that r of x is equal to this. So when I differentiate this, I'll get 0. When I differentiate this, I'm going to have minus 40 minus, when I differentiate this, I'm going to have 2x. So to maximize, it means that it's like we are finding the critical value. So r prime should be equal to 0. So this implies that r prime of x should be equal to 0. So this implies that minus 40 minus 2x is equal to 0. And we are going to have 2x is equal to minus 40 and x should be equal to minus 20. So that's what you are going to get. So we need to have x to be equal to 20. Now since we have x is the x equal to 20, then we can find the price that's going to maximize the revenue. So now our price will be equal to 60 minus 20, and this is going to give us a big 40 here. But let me check something here if we did everything right. So 60, 100 minus x. Okay. So I think something wrong here. This is, yeah, I think that's right. Yeah, that's right. Everything is right. Because this time this will be, okay, so I think I've seen this one supposed to be minus and this one supposed to be plus. Yes, because 60 times this minus and this time this will be that. So you see, that's what you need to do whenever you are doing this. So this is going to give us 40. So this will be positive. So the reason why I was checking was I had my x to be negative, which it's quite, so now this is also positive. So this one will be positive and this one will be positive. Good. So it means that this one will be plus and this is going to give me a big 80. Good. So you see, just negative, you see what was messing up the solution. So always make sure you pay attention to your minus and your plus. All right, let's look at question 4. U-substitution. I love U-substitution a lot. And this is kind of, they've given us all the information that we need to, do. So what is our U? So as I said, always when you want to pick your U, compare the function, the one with the highest degree. So we can see that this function has a highest degree, right? So my U will be x squared plus 1. That will be my U. Then I need du. I can get du from u is equal to x squared plus 1. So let me try and differentiate this. So du over dx will be equal to x 2x, because when I differentiate this with respect to x, this is what I'm going to get. We need du. So this is kind of divided by 1. So this will multiply this will multiply this. So this implies that du will be equal to 2x dx, right? So this is 2x dx. Is that right? Good. So what we need to do is, now we want to write this integration in terms of u. So let's look at this. So it means that we are going to have our integration that we want to write it in terms of x is x divided by x squared plus 1 dx. Now we know that this guy here is u, right? X squared plus 1 is u. So I'm grouping like terms. I'm replacing this one by u. Then I group like terms. So I'm going to have 1 over u times x dx, right? So I multiply this one by this. And x squared plus 1 is u. So now we need to look for x dx. So x dx can be found here. Since we have x dx here, then the only thing that we need to do here is we need to divide this one by 2, divide this one by 2. So this implies that the u divided by 2 is the same as x dx. So this helps us to replace this by this. So this is going to give us integration 1 over u du over 2. So this is what we're going to get. So the question is, write the integration in terms of this. So this is where we are going to end. But we can simplify it and then say this is the same as 1 over 2, 1 over u du. So the question is, write the integral in terms of u. So always pay attention to that. So now we're able to write the integral in terms of u. Now write your final answer in terms of x. So this is the final answer, right, that we need. So now we know that the integration x over x squared plus 1 dx is equal to, this is the final result that we had. So this is 1 over 2, 1 over u du, right? So this is equal to 1 over 2 ln of u plus c. You remember, right? So 1 over this, since the power is 1, we get the ln. And this is equal to 1 over 2. Now, what is u? What is u? We said u is equal to x squared plus 1. And this is going to give us x squared plus 1 plus c. So this should be the final results that we need to get out of this. Right. So more questions to practice, you'll be good with this one. But I think we have other version here. Good. So other version too, we need to pick our u, the same thing. We have one function here, we have another function in the parentheses. Which one is having the highest degree? The one in the parentheses. So here our u will be x squared plus 3. Same idea. For us to find this, we need to differentiate this. So what will be du over dx? 2x. Then this implies that du is equal to 2x dx. Is that right? So you can see that now this is equal to that. So this helps us to write this one as this dx. The same format for the first one. So integration x squared plus 3 to the power 10 dx. Now this is now equal to, now remember we chose u to be equal to x squared plus 3, the one in the parentheses here. So this one is going to be u to the power 10 times x dx. So what did I do? I moved this x to this x here. So x times dx going to give us this, and this is u to the power 10, which is also here. So now we need this guy here so we can find it here, like the one that we did. So here, the only thing that we need to do is we need to divide this one by 2, this one also by 2. So this is going to give us something like du over 2, which is the same as x dx. So we can see that this is also the same as that. So this is going to give us integration u10 times du over 2. And finally, 1 over 2 u to the power 10 du. So now, finally, we need to write our results in terms of x. So x squared plus 3, x to the power 10 dx. This is the same as 1 over 2 u to the power 10 dx. So let's do the integration before we write our final answer in terms of x. So 1 over 2, this is going to be U11 divided by 11 plus C. We know U to be the same as x squared plus 3. So our final answer here is going to be U is x squared plus 3 all to the power 11 divided by 2 times 11 is 2 plus C. So this is what we are going to get at the end of this. This is the U substitution, basically. Yeah. So that's what we need to get. Let's look at question 5. So question 5 is evaluate the integrals, right? So let's see what we can do here. So as I said, with integration, some of the question you need to simplify before you go through the integration. So this is one of them. We need to simplify. So this can be written as 6x 1 over 2 minus e to the power 2x dx. So now that we are done with the simplification, we can integrate. So this is the power rule. So 6x 1 over 2 plus 1 divided by 1 over 2 plus 1 minus. Now when you want to integrate an exponential function, maintain the function divided by the derivative of what is on the top, right? So when I differentiate what is here, 2x, I'm going to have 2. This is indefinite, so I need to add plus c. Let me just simplify what is here. 6x to the power 1, 3 over 2 divided by 3 over 2 plus e to the power 2x divided by 2. And finally, we can write this one as, so we have 6 divided by, so let me write like divided by 3 on 2. So this is 6 times 2 on 3. 3 goes to itself 1, goes here 2. 2 times 2 is 4. So this is going to give us 4x to the power 3 over 2 minus e 2x minus divided by 2 plus c. So this is what you're going to get at the end of the day. All right, let's look at D, B. So this one too, we need to simplify before we can go through. So this is the same as integration, 24x to the power negative 5, right? Plus 8x to the power negative 3, or the x. So we saw that this is not 1, this is also not 1. So we are going to have this to be 24x to the power minus 5 plus 1 divided by minus 5 plus 1 plus 8x to the power negative 3 plus 1 divided by minus 3 plus 1 plus the constant. The constant is very important. So 24x to the power negative 4 divided by minus 4 plus 8x to the power negative 2 divided by negative 2 plus 6. Simplify. 4 goes to 24 how many times? I think 6. Yeah. So this is going to give us negative 6x to the power negative 4 minus 2 goes to 8, 4. So minus 4x to the power negative 4 plus c. So we can just end our final results here. Let's look at the last part in this question. So this is a polynomial function. So we don't need to do any simplification. All we just need to do is we just move straight to the integration. So let's integrate this. This is 10x to the power 4 plus 1 divided by 4 plus 1 minus 9x squared plus 1 divided by x divided by 2 plus 1 plus 4x1 plus 1 divided by 1 plus 1 minus 7x plus a big C. So just add 1 to the powers divided by the same thing here, the same thing here, the same thing here. So this is going to give us 10x to the power 5 divided by 5 minus 9x to the power 3 divided by 3 plus 4x squared divided by 2 minus 7x plus the big C. So the final result here is going to be 2x to the power 5 minus 339. So 3 plus 2x squared minus 7x plus the big C. So this is what you are going to get at the end of the integration. Let's look at question 6. So when a question is asking you to find f of x, then it means that we are looking for the function that we differentiated to get this. So since this is differentiated, we need to take the entire derivative. So we are going to have integration of f prime of x dx. So we are taking integration on this side and the same time integration on this side. So this will be integration x squared plus 5 dx. Is that right? So let's go through the integration. This is going to give me f of x. Then when I do the integration for this, I'm going to have 6x to the power 3 divided by 3 plus 5x plus c, because this is indefinite. So this is going to give us 2x cubed plus 5x plus 6. So when I was marking the script, I saw that some of you were getting this one right without adding the c, which you are going to get some deduction. And then some of you were not also able to find the c. And some of you too, when you are dividing 6 over 3, you write here 3 instead of 2. So making your solution kind of some errors. So this is f of x, but we need to find a constant c because they've given us the initial condition. So anytime you are done with this one and you want to work with this one, this is plug in 1 inside this and it should be equal to 10. So this is f of 1. So this is going to be to the power 3 plus 5 times 1 plus c, right? Now, don't forget, f of 1 is equal to 10. So I'm going to have 10 equals, this will be 2 plus 5 plus c, right? So if you want to just look at it, when you add, this will be 10 plus 10 is equal to 7 plus c. Then it means that when c is 3, we are going to get 10, and this is going to be kind of c should be equal to 10 minus 7, and this should be equal to 3. So our c here should be equal to 3. So therefore we can conclude that our function, let me write it on the top here, our function f of x is equal to 2x to the power 3 plus 5x plus 3. Yes. So this should be the function. So it means that this is the function that we differentiated to get this. So let's see. When I differentiate this, 2 times 3 will be 6. Subtract 1, which will be 2. When I differentiate 5x, I get this. And when I differentiate the constant, it is what? 0. Let's look at the other version. The same thing. Pick the function and integrate both sides with respect to x. So 10x minus 7 or the x, right? So you can try this one too on your own. So when I integrate this, I'm going to have gen of x, which is equal to, so 10x squared divided by 2 minus 7x plus the c. So simplify this and you see that you have your gen of x to be equal to 5x squared minus 7x plus c. Let's find for c using the initial condition. So gen of 1 is equal to 5, 1 squared minus 7 times 1 plus c. Gen of 1 is equal to 6. So I have 6 is equal to 5 minus 7 plus this. So this is going to give us 6 is equal to minus 2 plus this. And c should be 6 plus 2, and this should be equal to 8. So it means that our function gen of x is going to be, gen of x should be 5x squared minus 7x plus a big 8. So that's what I'm going to get at the end of the day. Good. 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 So that's what we are going to get at the end of the day. So we are done with question 6. Let's look at question 7. So question 7, first we need to find the derivative of h, right? H prime. So let's do that. H prime is equal to, this is a polynomial function, so we can just do it straight. So this is 3x squared minus 6x minus 9. Right, but the follow-up questions, we need local max, local minimum, increasing and decreasing. It means that when we are done finding this, which the question was asking us, we need to find the critical values and using the sign chart too as well. So let's do that. What I can do here is I can factor 3 out. I'll have x squared minus 2x minus 3. And then now look for two factors or two values. When I add, I'll have this, but when I multiply, I'll have this. So basically 2 and 1. So this is 3, x squared minus 2x. So 3 rather, plus x minus 3. Good. So this is going to give us 3 x out, x minus 3 plus 1 out, x minus 3. So this is what I did. I just picked this first term and I picked the second term. So this first term, I factor s out and to be left with x minus 3. This one, I have the x minus 3 already, so I can just bring 1 here. So I'm going to have 3, open bracket, x minus 3, and then I'm going to have x plus 1. So when I factor this and this out, it will be left with x plus 1. So what will be x? I saw this that anytime you have something like you are confused with this constant. So you'll be picking the constant and equating to 0 and you'll be saying that x is equal to 0. No. The constant that you have here, it's not with x. So this is like kind of going away. For example, if for critical values, I know that h prime should be equal to 0. So it's kind of like 3x minus 3x plus 1 is equal to 0. So for me to solve, I need to divide 2 by 3. So this is going to be x minus 3, x plus 1 is equal to 0 because I've divided 2 by 3. Then we can see that x should be equal to 3 and x should be equal to negative 1. Is that right? So the critical values, s is equal to negative 1 and s is equal to 3. So that's what you're going to get. Now, since we've gotten the critical value, the important thing that we need to just do here is just sketching the sign chart. So we are going to have negative 1 here and 3 here. Now, with local maximum and minimum increasing and decreasing, we use the f prime. We use the derivative function, right? So this is h. So let's pick h prime of anything before negative 1. So you can pick negative 2 here. In between negative 1 and 3, and let's do the smart move, picking 0 because this is a polynomial function. And then here we can pick 4. So let's plug it in. Sorry, this is a polynomial function. So let's plug it in and see. So now we know that h prime of x is equal to 3 x minus 3 x plus 1 from here, from the simplification. So when I plug in minus 2, minus 2 minus 3, this will be negative. Then when I plug in minus 2 here, minus 2 plus 1 is also negative. So I have negative times negative, which is going to be positive. So it means that this is greater than 0. So this is positive and this is going to increase. Let's plug in 0. 0 here will make this one negative. 0 here will make this one positive. Negative, positive is negative. So this is less than 0. This is negative and this is going to go down. Let's plug in 4. 4 here will be positive. 4 here will be positive. Positive, positive is positive. So this is going to be plus, and this is also going to move up. So after we are done finding H prime, finding the critical values, we need to use the sign chart. When we are done with the sign chart, then all these questions are just bonus, right? Because we've done the hard work already. So we just need to look at what we just need to put there. So what's the X value that is going to give us the local max? So that's the one that is giving us maximum, right? So from positive, negative is the maximum. So this is when X is equal to -1. That is the critical value, right? So we have the maximum turning point here. And then the local minimum will turn here where we have negative, positive. So this is what we are going to have here. So X should be equal to 3. Now, why is the increasing? Why is the function increasing? So we can see that the function is increasing from here and from here, from negative infinity up to -1, and from 3 to positive infinity. So we have from negative infinity up to -1, and from 3 to positive infinity. And then, of course, decreasing is the one which is in between -1 and 3. So this is -1 and 3. So you see what we just did? We just found the H prime, finding the critical values, drawing your sign chart, and all these questions were just a bonus question from the hard work that we did here. Let's look at question 8. Oh, okay. We have other version here. So let's go to another version here and see what we are going to also get. So the same idea, we need to find H prime. So H prime of X, this is going to be 3x squared minus 12. Oh, this is nice. So what can we see here? This one is good for us to know that for critical values, H prime of X should be equal to 0. So 3x squared minus 12 should be equal to 0, right? So what can we do? Here we can factor 3 out. X squared minus 4 should be equal to 0. Divide through by 3. So I divide this one by 3, divide this one by 3. I'm going to have x squared minus 4 is equal to 0. Now this is difference of two squares. So I can write this one as x minus 2, x plus 2. So you see that this is not difficult to see that x should be equal to 2 and x should be equal to -2. Now if you don't see that this is difference of two squares, then from here, this is what you can do. From here, you can write this one as x squared is equal to 4, right? And then x is equal to square root of 4. And this is going to be plus or minus 2, which is the same thing here, right? So without wasting my time, let's just draw the sign chart. We have -2 here, we have 2 here. So same idea, h prime of -3 before the -2, and in between I do my smart approach by choosing 0, and then after 2 I can choose 3. So let's check by using h prime. So h prime is equal to 3. So if we are using the last simplification that we did here, or even if we are using this one, we are going to have 3x squared minus 4, right? And we saw that this is the same as x minus 2, x plus 2. Now, I try to simplify it so that when we are plugging in the value, we don't struggle. So -3 here, -3 here is going to give us negative. This is also going to give us negative. So we are going to get positive. So greater than 0 plus increasing. Plug in 0, 0, 0, negative, positive will be negative, so less than 0. So coming down, and then the last one, plug in 3. Now plug in 3, positive, positive, so it's also going to give us greater than 0, and this is also going to increase. So hard work is done. Let's go and enjoy our B, C, and D, and E. So local max is x is equal to -2, and local minimum is x is equal to 2, right? So local max is positive, negative. So local max happening at -2. Local minimum is, oops, this one's supposed to be negative. Local minimum is negative positive, which is the concave up, right? So we are going to have this one. Same idea from what we just did. Increasing is from -infinity up to -2 and 2 to positive infinity. So -infinity up to -2 and from 2 to positive infinity. And then the decreasing interval is between -2 and 2, as we saw from here. So this is where the interval is decreasing. Let's look at question 8, concavity, right? So that's what we need to look at. So whenever we are talking about concavity, we are talking about the second derivative test. So it means that first we need to find gen prime prime. We need to find the second derivative, right? So let's go through that and see what we are going to get. So we have gen of x to be this. So what is gen prime? Gen prime is equal to 3x squared minus 30x plus 4. What is gen prime prime? Gen prime prime is equal to 6x minus 30. So for us to talk about concave up and down, we need to talk about point of inflection. So what is point of inflection? Point of inflection is like critical values, where we say for critical values, the first derivative should be equal to 0. Now for point of inflection, gen prime prime or the second derivative should be equal to 0. So this implies that 6x minus 30 should be equal to 0. 6x is equal to 3x. Divide through by 6, and I think this one is supposed to be 5. Right. So now we are getting the point of inflection to be 5. So like what we just did from here, after finding the critical values, we need to use a sign chart. The same idea here. So after finding the second derivative, finding the point of inflection, we need to use the sign chart. So let's do that. Sign chart. This is just one value here. Don't forget we are using the second derivative. So this should be equal to 6x minus 30. So pick a value here, which is before 5 is 4, and after 5 is 6. Let's plug 4 here. Now 6 times 4 is 24. 24 minus 30 is -6. So this is negative, right? This is negative. So kind of decreasing. 6 is 36. 36 minus this is going to give us +6. So this is positive and kind of increasing. So what you just need to know is anytime you see negative, that is concave up, right? So this is concave up. And then anytime you see positive, this is concave down. So this is going to give us concave down. So the question is, for what value of x is the graph concave down? So for the x values, for concave up, we need to look at from -infinity up to 5, right? So from -infinity up to 5, it's kind of telling us that, okay, there is concave up somewhere. And then for concave down is kind of from 5 to positive infinity. So we are going to have from 5 to positive infinity. So you see, this kind of questions, they are not difficult. All you just need to know is, you know the procedure. You know how to take the derivative, and you know that, okay, I'm using the second derivative to find the point of inflection, use my sign chart, and then now I look for the concave up and down using whether it's positive or negative. That's all. Now let's look at other version too. So other version, the same idea. Gen prime is 3x squared minus 12x plus 4, and gen prime prime, this is going to give us 6x minus 12. So same point of inflection, chain prime prime should be equal to 0. 6x minus 12 is equal to 0. 6x is equal to 12 and x should be equal to 2. Same idea, we need to put it on a normal line, 2 here, and then we are using chain prime prime of x, which is equal to 6x minus 12. Plug in a value before 2, let's pick 3, and after 2, let's pick, before 2 should be 1, and this one rather should be 3. So let's plug in 1 here. 6 minus this is definitely going to give us something like less than 0, which is negative, and this is going to be like going down, right? And then putting 3 here is 18, and this is going to be positive, and this is positive and kind of going up. So this is going to give us concave down, and this is going to give us concave up. Good. So down, up is from negative infinity up to 2, and then down is from 2 to positive infinity. So for concave up, just use the signs. Remember, when it is negative, that is when we are talking about the up. So the up, like, you see, anytime it is negative, like for example, this is negative, positive. So this is kind of like minimum turning point, right? So whenever it's negative, remember, we are talking about the minimum. So like kind of up. And anytime it's positive, we are talking about maximum. So kind of concave down, right? Let's look at question 9. Question 9, I love them, right? So now they give us a point here, a point here, a point here, a point here, and a point here. So first, let's figure it out. The point here means that x is 8 and y is 0. So it means that at this point, we have negative 8. At this point, we have negative 4. At this point, we have 2. At this point, we have 6. And at this point, we have 10, right? So it means that we are moving within range. We are moving within minus 8 to minus 4, minus 4 to 2, 2 to 6, and 6 to 10. And then the question has given us the area. So area A is equal to 5. Now don't forget, anytime your graph is below the x-axis, your area should be negative. So it means that since area A is 5, it means that since this one is this, we are going to have this to be negative 5, right? So let me use a black. So negative 5. Now area B is 7. So this is equal to 7, right? We are going to have 7 here. C is 8. So we are going to have C to be equal to 8. And then D is 8. But because it's below, we are going to have it to be negative 8. So that's what we need to do now. Now let's come here. We want to integrate from negative 8 to 2. So where is negative 8 to 2? Negative 8 to 2. So negative 8 to 2, we have two graphs. We have A and B. So this is equal to A plus B. What is A? A is negative 5. What is B? B is 7. So this should give us a big 2. Now let's move from 2 to 10. Where is 2? 2 is here, and we are moving it up to 10. So we have C and D adding. So this is equal to C plus D. C is 8, D is negative 8. So this is 8 minus 8, and this is giving us 0. Let's move from negative 4 to 6. Negative 4 to 6 is having B and C. So we are adding B plus C. So B plus C. B is 7 and C is 8. So this is going to give us a big 15. Yeah. So this is kind of very simple to do them. Right. Let's look at question 10. This is the last question. So question 10, we have the this and then we have x is equal to this, and we want to find the revenue function. What is this? So now we know that revenue function, so here always pay attention to, so this is the revenue function, but we have x here, right, which is equal to this. The function is in terms of p, right? So since r is in terms of p, we need to change x so that our final results will be in terms of p. So here, if you make mistake by making p the subject and doing substitution, don't forget this, your final answer will be in terms of x, but this is p. So it means that here it's good for us to just do 60 minus p squared times p, because now x is equal to what is here. And then when you multiply, we have 60 p minus p to the power 3. So this is what you are going to get at the end of the day. So this is r of p, and our final result is also in terms of what? P. Now the question is, find the price p which maximize revenue. Now we want to find price that maximize revenue. And now our revenue is in terms of price. So all we just need to do is we need to just differentiate it to get p. So r prime of p is equal to, let's do the differentiation. What do we get when we differentiate this? This one will be 60 minus 3p squared. Now for x to maximize, then we need to find a critical value. That is when this is equal to 0. So r prime should be equal to 0 to maximize the revenue. So 60 minus 3p squared is equal to 0. So 3p squared is equal to 60, and p squared is equal to 20. Yeah. Then here we take the square roots, right, on both sides. So square root of p squared, square root of 20. This is going to give us, this will cancel this. So p should be equal to square root of 20. So this is what we are going to get. So this is the price that we are going to have, right? This is the price. This is the price that we are going to get. Now the question is, now the last question is, state the maximum revenue. So since this is the price that is going to maximize the revenue, then for us to get the maximized revenue, we just plug in p inside the revenue function. So we know that r of p is equal to 60 p minus p to the power 3. So let's plug in p. R of root of 20, this is 60 times root of 20 minus root of 20 to the power 3. If you cannot simplify this, you can just leave it like that, and then you are done, right? So that's all you can do if you cannot do this. But for me, if I want to simplify this, this will be 20 root of 20 minus, this is going to be 20 root of 20, because this is kind of root 20 times root 20 times root 20. Root 20 times root 20 will be 20 times root 20 will be this. So this is what I'm going to get. So my final result here should be 40 root 20. Is that right? So that is how it is. That's what you're going to get. Let's look at the other version of this, and then we are done with this video. So same idea. We have x. The function is in terms of p. So we need to do same thing again. So r of p is x times p, right? And then x is 600 minus 3p times p. Multiplied through, and we have 600 minus 3p squared. Same idea. For us to find the price to maximize this, we need to find revenue prime, right? The marginal revenue. So r prime of p is equal to 600. Oops, this one should be p here. So 600 minus 6p. So for us to maximize the revenue, 600 minus 6p should be equal to 0. So 6p will be equal to 600. and P should be equal to 100. So this one we're able to find a fixed P. And then the last question, which we are going to write it very big, bold, is now we want to maximize, we want to state the maximized revenue. So let's put 100 inside that. So R of P was equal to 600P minus 3P squared. Now P is equal to 100. 600 times 100 minus 3 times 100 squared. So this is going to give us 6 4 zeros. So this will be 60,000 minus 3 times 100 squared should be 4 zeros. So this one will be 30,000. Or let me just write it this way. This is going to give us 10,000. So 60,000 minus 30,000 will give us a big answer, a big 30,000. So this is the end of the video, right? So this is all you need for you to get prepared for your final exam or to take exam on exam 3, right? So in the next video, I'm going to talk about final format, right? What we are going to do on your finals, right? We are going to talk about final exam, which was on spring 2024. So that's what you are going to go through so that you can have the real format of how final exams is. So see you in the next video.